All right, we're going to welcome up Christian and Colin for the talk Prescribing Rx Responsibly.
Hi everyone.
Yo.
Alright, so as Narek said, our talk is Prescribing Rx Responsibly. Quick show of hands, who has used Rx in some form? Okay,
Whoa.
that's probably more than half, pretty good percentage. Okay. So today we're going to talk about what is Rx. That's going to be pretty brief. It seems like most of you are familiar with it. Then we're going to dive into some examples from our code bases that we've used. Basically when it's a good time to use Rx and when it might not be a good time to use it. Then we're going to go into some best practices like operators, extensions, etc. Some basically pro tips, and then talk about some conclusions. All right. So what is Rx? Okay, so we have this state-of-the-art diagram that we put together. Basically, Rx is a huge topic, and today we're not talking about what Rx is. We're just going to give you like the bare minimum to set up our examples. It's a very deep topic, so we're just going to sort of give you an abbreviated overview. So what is ReactiveX? It stands for Reactive Extensions. I'm going to read literally the description from their website. ReactiveX is a combination of the best ideas from the observer pattern, the iterator pattern, and functional programming. Those three topics could easily be a whole series of talks. So we're basically going to focus in on the observer pattern, which is probably the most relevant. There's different flavors of Rx for every platform. We're of course going to be focusing on RxSwift today, Swift implementation. And essentially what Rx is, it's a declarative way to define the data flow in your app and the way to handle events and timing in a nutshell. It helps us avoid callback hell, which I'm sure everyone here has experienced at some point. And really the most important concept in Rx is the idea of streams. So basically a stream is just a series of events over time. So you could have a stream of anything. It could be a stream of primitive type or custom type. It's very useful, it turns out, for MVVM. At Intrepid, we are sort of big evangelists for the MVVM structure. So we use binding a lot between our view models and views. It's also very useful for handling asynchronous data, so like events from Bluetooth devices, asynchronous web calls, etc. Alright, so Rx Marbles, I'm sure some of you have seen it. It's basically a website with interactive diagrams to help you wrap your head around how Rx streams work. This is a very obvious example, but just to get the point across, you have some stream, time is left to right obviously. You have some stream of abstract objects, you do some operation on that stream. In this case we're filtering to get circles basically, and then that gives us a new stream. So if you subscribe to this stream, you just get circles. Again, a trivial example, we're doing a map function on stream, creating diamonds from circles. Rather simple, but it becomes very powerful when you chain a lot of these operations together. And that's going to be the focus of some of our examples. So the sort of the ecosystem in the world of Rx, there's a lot of different entities. And we're not going to go into all of them today, because that could be a much longer talk. These are basically the big players. What we're going to focus on today is observables, variables, and dispose bag. An observable is very simply a thing that emits an event, and which you can subscribe to receive the latest events. A variable is similar, but it lets you actually set an event as well as subscribe to it. And lastly, a dispose bag is basically this concept of cleaning up your memory. So if you're subscribing to an observable in a given class, you need to add every subscription to this dispose bag instance on your overall instance. And that way when that class gets deallocated, it cleans up all the subscription references. And that'll be in pretty much all of our examples, as you'll see. And just one other thing, variable is very useful for MVVM. We use that a lot in Intrepid. We have properties in our view models. where internally in the view model we'll set state, and then externally, usually in the view, we'll subscribe to that. So now we're going to talk about some cases of when to use Rx.
So this section we take a lot of excerpts from the project that we work on at Intrepid. Basically, just showing some of the experience we've been using Rx and maybe some of the pain points that we found at using it. We try to categorize the use cases for Rx into the 4 things we're showing here, but they're not very set in stone, hard drawn lines between them. So we briefly talk about user interactions like getting button clicks and text field changes. Asynchronous operations like processing network calls and maybe data on a background thread. Creating bindings between view controller, view model, and model. That's a big thing that could cut down a lot of code if we're not using Rx and prevent code spaghetti. Eventually, that's the end goal. So let's dive into things in code. This is the most simple example we have. Just to subscribe to the tab events of a logo and triggers a function called, if we're not using Rx, we have to create IB action functions. But it gets complicated if it's a view inside of the nib that it's also a custom view class with some other outlets set up. So with Rx, you can just basically set up expose your variable here and bind it to a function that you want. Similarly with date picker, the Rx date, so RxSwift is doing some smart stuff that expose a lot of properties with the Rx namespace. You can use the dot property syntax here to get the Rx date, and then we bind it to the end date in the view model. If we're not using it, then we have to resort to IB action methods. And just to point out, we're using some of the custom operators that we define ourselves. We'll be covering those in the best practices section. This is one of the interesting cases. We're using a two-way binding between a UI control event and a variable in the view model. So whenever something updates on either side, the other side gets updated. So if the user types something in the text view, the text view's Rx text property gets updated, and it triggers the view model's title getting updated. And if the model, maybe something changes the view model's title and gets reflected on the UI as well. If we're not using Rx, then probably you have to set up the delegate method as well as some disset method in the view model to achieve a two-way update effect. So something we also try to achieve is that there is a nav bar, but then a table view underneath it. So whenever the user starts scrolling, we want a gradient shadow to show up to kind of hint that the table is underneath the nav bar. And what we've done is creating an extension on the scroll view. We're going to show that in the extension section as well. So basically, whenever the table gets scrolled under the top, we're telling the view model to show the top gradient, and the view model tells the view to show the high gradient. Without Rx, we have to repeat the code many times across different view controllers in the delegate method and do the calculation, which is not dry at all. This we can probably skip because we have a lot of code here, but the takeaway point is that we're using observable.concat to basically let the next observable stream to wait for the last one before it continues to fire. And what we can set up is we subscribe to it. Oh, it's the wrong order. Okay. We subscribe to it in the view model, and then whenever we want to get the next page, just call fire, trigger. Let's go back to that one. Yep. Some interesting use of it is we can chain network calls together to create a single observable result. What we're trying to do here is we're telling the server to give us a precise URL to upload the image, and then we upload the image, and then we set up the URL of the image to an object that we're trying to upload to the server, and then we get the result in the observable. So it's chaining 3 different things together. We create a request, subscribe to the result of the request, and then create another request of upload image, and map the upload image result to the next request to start sending out data to the server. That's a powerful side of Rx mapping functionality. And another nice thing about Rx is that a lot of users and developers have been developing on it, so we get lots more of libraries and tools we use by developed by other people. This is one example of it. What we want to achieve is we can have a single source of information that tells us whenever the user's device loses connection to the internet. And this guy has written this service. Well, when we try to use it, we can just simply subscribe to the reachability observable and show and hide a toast message based on their connection status. Similarly, with the Bluetooth stream, we have a device manager that monitors the connection between the device and the user's phone, and whenever the battery status changes, just modify the battery image. Something to watch out for is the stack trace hell. So if you are getting out of the callback hell into the stack trace hell, you'll see in the crashlytics log that if you're crashing and you're using RAM and Rx together, you get 20 stuff from RAM and then 15 stuff from Rx and nothing from your program code that helps you debug. So watch out for that. The next section is best practices.
Okay, so I'm going to run through some best practices that we've discovered. First one is operators. Pretty much all the examples we've shown you have been using these. So these are the operators we typically use. Triple chevron is add to dispose bag. So in vanilla RxSwift, you'd write dot add to disposable dispose bag. It's a little more verbose. Also for binding, all the arrows you saw, that's basically custom operators. Normally it would be like dot bind to or dot subscribe next, but operators are awesome. They make the code a lot cleaner and easier to read. So either write your own, or there's a lot of good pods out there. Our Swift Wisdom pod has some of these defined, so it makes things a lot easier. This is the two-way binding operator that Colin showed earlier. It's not too bad, and it works really well. So if you ever want to update the view model as you type, for example, and then if the view model gets updated, then update the text fields, things like that. Turns out to be really useful. Yes, scroll view extensions. So also Colin showed using this earlier. Turns out to be really nice use case to write an extension on the scroll view itself. So we just have two observable booleans. So it's just a stream of true or false, and anytime it changes, you can just fire your subscription. So it just tells you if it's underneath or not. There's a lot of cool stuff you can do like this with views in particular, and there's a lot of good pods out there as well. This is a gotcha. As we all know, as most of us are probably awesome iOS developers, cells get reused in table view cells, collection view cells, etc. And since this is Rx, we need, if we're binding to something in our cell, we need to add it to our dispose bag in the cell. Problem with that is if the cell gets reused, then you end up with multiple references in dispose bags they probably shouldn't be in. So you just need to make sure that you create a new instance of your dispose bag anytime the cell is reused. Because that's caused us some funky bugs, so it's a good one to look out for. This one is more of just an organization thing. It's good to have a designated method for where your binding happens, specifically in your view controller. So one approach we follow a lot is just to have a bind to view model method, and then you just call that in your view did load, and then you do all your bindings in there. If you have a ton of them, obviously you can have some private methods to sort of break it up. Another approach we do sometimes is actually bind things in our did sets, because at that point you're guaranteed that the nib is loaded, the outlet reference is set, and you can bind things there. So it ends up being pretty clean. Another best practice, if you need, so this was actually for client projects. They basically had Bluetooth devices that were feeding into this device manager, and internally they had a set state and managed state. So they wanted to have an observable property on that they set, but they also wanted to be able to only provide consumers of that device manager the ability to subscribe, but they don't want consumers to set any values. So basically they just had a variable, a private variable, meaning you can subscribe to that internally or set that internally, but you can't do anything externally. And then the public API is just that variable as observable. So that's a pretty standard approach to handling public versus private observables. This was actually similar use case. So there were Bluetooth devices, and the Bluetooth device would send essentially a ping every so often. And if we get a ping within 60 seconds, we consider it connected. And if we don't get one within 60 seconds, we consider it disconnected. So we have to flip the state. It turns out the built-in timeout operator in Rx is a little limited in that you give it a time value and it can time out, but once it times out, the stream is terminated because it emits an error. And in Rx, when an error is emitted, that's typically the end of the stream. But we're able to basically take the original stream and then merge it with a debalanced version. So basically the debalanced version only fires when that time elapses. And then by merging those, you get a single stream of connected events and a disconnected event whenever that time elapses, and it keeps going indefinitely. So that's pretty useful. All right, so that's pretty much all the examples we had. We're just going to talk about some conclusions now. Just a few questions that we thought were good to sort of ponder. If you're either considering using Rx or already using it and about to add it to a new class or something, what are you reacting to? If it's a UI event, like if it's just a button action or a text field event, sometimes it might be easier just to use the delegate method or the IB action. If it means you're importing all of RxSwift just to do these bindings, it's probably not worth it. But if you're already using Rx in another part of your app extensively, then you might as well use it. So there's trade-offs. Are using a struct or a class. Something to keep in mind is all these observable entities in Rx are reference types. And structs, since they're value types, are going to get copied a lot here and there. So we tend to use classes if there's one or more observables or variables. Observable versus variable, I kind of touched on this, but only use variable if you need to be able to set the value ad hoc, like set a new event on the stream. Very useful for view models. That's probably where we use them the most. And an observable you can basically think of as a pipe. It just gives you the next value. So it's a little more simple. Does the subscription need to update things on the screen? Make sure it's on the main thread. In Rx you can say subscribe on and then give it the scheduler you want it to use. So just make sure that's on the main thread, or else you have some weird bugs. And lastly, will the view update when it's being displayed? If you're binding something to your view, but you don't ever expect that or want that to update while you're looking at the screen, you might as well just do that in view to load when the screen is first loaded. Because we fallen into the trap a couple times where we get so used to binding things in our view that we would use it in a couple places, and then later realize that those are never actually going to update while you're looking at the screen. So it's actually more code than is necessary. Okay, just some closing thoughts.
So, picture copyright Christian Howland for the thinker.
I made the picture.
So we think that Rx is a very powerful binding tool, especially for MVVM pattern, because of the things that need the information that needs to be passed through both ways. And if you're not using Rx, you get a lot of boilerplate code to glue it together. And the mapping functionality could be very powerful for processing data and do all the stuff you want in the flow, in the stream pattern. We can probably simplify or complicate code a lot depending on how you use it. So, or on the simplification side. Pain points, as we talk about using Rx with REM, which is a data store service if you've never used it before. It's kind of painful sometimes. But overall, definitely, it's converging on many platforms. We've seen RxJava, RxJS, RxJava, RxSwift here and there, so definitely a good thing to learn if you haven't started using it. Some useful links if you want to learn further the marbles. The diagram that we've been showing, written JavaScript. ReactiveX.io is the mother project of all the stuff, so definitely check it out. Our own Swift Wisdom is a very nice resource that you can easily use to improve your workflow, and it has a Rx portion of it. Check it out, the Rx Swift repository, and join the Slack channel. They're super helpful if you have questions regarding Rx. And question time if you have any. Yeah, go ahead.
How do you think using Rx affects your ability to test your code? Like, do you think it makes it easier or harder?
I don't think it actually relates to how you test your code.
So it depends on. So yeah, if you want to test your observables, you normally have to pull in like. The last project I was on, I pulled in Rx Nimble. It's basically like an Rx version of Nimble. So it allows you to block your observables. Or else the only other option is to like put in sleeps, which is not a good option. So there's libraries out there to help you do blocking. And you can just put expectations in those. I think there's a variety of libraries out there to solve that. I haven't used all of them, but Rx Nimble is a pretty good solution.
So there are no test packages available for RxSwift? For example, the subscriptions or observers that gather events, and then when you know something done, you just do assert events, a certain number of events, assert error.
I mean, Rx Nimble sort of operates in that way, but there's nothing like, I don't think there's any like official Rx.
But that wouldn't block, because if you start blocking, your test might hang.
No, so it doesn't block the queue, it blocks like that observable, like it gets the next value. Basically.
So it's not too blocking or something like that.
Right. Yeah, it doesn't literally block the queue, it just like
Okay.
blocks that stream so you can check the next
Okay.
subsequent value.
I have two questions. So you have like observables, variables, you also have drivers. What is a driver? Where would you use a driver? And also you mentioned schedulers. I know you have like a main scheduler. What is an example of a context in which you set another scheduler? What's that useful for? I know it's part of the API. I've never used it myself. I'm just curious.
So drivers, I don't think I've used, to be honest. This gets back to like Rx is a very deep library. I think they're basically for like, I think they're like the originating source for elements. Like if you were creating a low down thing that creates these events, I think you would use them in that scenario, but I'm really not sure. Do you know?
So I think driver, you actually use it to update UI stuff mostly. Some of the things that we've been seeing is we use observables, and then you have to manually set up, maybe replay the last value and all sort of stuff, maybe and stream errors out, and you have to manually set up on error just replay kind of thing. The driver does that all for you. Always emits event on the main queue and always replay the last value whenever it errors out, I think.
Oh, it always emits the event on the main queue.
Yeah, I think so, yeah. This for UI binding.
I learned something.
Usually it's for driving UI changes.
Gotcha.
What's your other question again?
Oh, schedulers.
Yeah, so main scheduler is, I think, is mostly what we use if we were at any point try to specify a scheduler. Basically, it just schedules the subscriber on the main queue instead of on whatever queue you create the subscription on. But I think you can create your own scheduler with a identifier.
And then, but that just basically maps to the specified queue, right? Like, I think they basically map one-to-one to queues.
Yeah, got it. So you would like initialize the scheduler with a queue or something, and then.
I think so, yeah. I've never done a custom one, I've only used main instance.
Same.
All right, we'll go over there first.
What are the main benefits to using an RX subscriber versus something like KVO directly?
Gets clear. The syntax gets clear. So, well, of course, like not only subscription, you can also use notification center to emit everything that you change, and you pull a new value. But Rx just makes everything more clear, and it's a declarative way to define the relationship between the mission of the event and the subscription of the event.
Yeah, I don't know if you can definitively say one's better than the other, but we've found RX is just cleaner and a little easier to sort of wrap your head around.
And do you know, quick follow-up, if RX is using KVO, or sort of how is it sort of creating those streams on it?
I think it is.
I'm not sure if anyone knows. If anyone knows, feel free to.
Just some armchair reverse engineering, I think, just based on the fact that UI kit support for KVO is so fickle, that they're probably just doing all the hard work of subscribing to the right notifications and delegates and things, and then wrapping it up in a nice API, would be my guess.
Yeah.
So you mentioned the stack trace health. Is there any, like, do you think that's like literally a tooling problem? Like, there needs to be something other than like Crashlytics or something that does a better job at it, or do you think it's just something that can't be avoided?
Unsolvable.
Yeah, I'm not sure how that could be solved because the place your app is crashing is separate from the place that it's emitting the signal, right? Just like if you set up a notification center subscription and at some point you're emitting a notification, at some point your app is receiving it, dealing with it, and then crashes. It's hard for you to trace back to where the signal gets emitted. So it's probably the same with RxSwift, is that for your debugging purpose, you probably want to trace it back to, like, for example, where your web service call is getting initiated, but you're getting your crash at the result. The problem with the combination with the Rem and Swift is like it creates 40 lines of 40 layers of call return stacks, and somehow the first one kind of gets lost. So if you're doing your subscription in your view model, you hope that you can trace back to your view model where you're doing all the work. It's not in your stack trace. Not sure. Maybe something could be done to improve that stack trace, but I'm not sure. Haven't looked as deep into that.
Does anyone know? Sorry, question.
I'm just wondering, because I know Rx well, with the, we talk about schedulers. Schedulers are not only tied to a queue, but also a thread, usually. So that's the whole advantage that Rx offers as well. You can, kick off a lot of fetching of data, for example, on various threads, and then use Rx to coordinate all of them. So I need to get all these and these before I go next, and then to the next system, instead of you doing all that work yourself.
Yeah.
Is there on RxSwift also such things as the subscribe on the scheduler and then observe on,
Yes.
observe on, observe on different threads?
Yep. Yeah. We have.
Okay, so that's the same thing.
Yeah. Yeah, it's very useful.
Yeah.
On one of our projects, we basically have like a data cache layer, and then that talks to the network layer. So we just subscribe to the data layer, then it does all the work of doing network requests if it has to, and then doing that on whatever queue it should be. And then all we care about is we subscribe to it, and it gives us what we want. So.
That's where just stack trace how comes into, especially when you have different schedulers, because different threads might raise those stack traces and what we said.
Nice.
But that's a general problem.
This is a general problem. Even on Java, you have to wait to roll it. Like, I think here something.
Yep. Other questions?
Can you speak to any performance differences one way or the other using RxSwift versus standard practices?
I cannot. Can you? Can anyone?
I think it's slower because it adds more stuff to it.
Seems plausible.
Yeah.
Thanks. I didn't follow up to that. All right.
Abstract stuff out usually that's more expensive.
Do you see performance differences in compile time with Rx?
Oh, definitely takes longer to compile,
Thanks.
for sure. and it crashes Xcode more.
I mean, it's another library, so obviously it's sort of
Very bad case.
Yeah, it does, not that confusing Xcode is hard to do, but it does confuse Xcode sometimes, especially when you have custom operators and like chains.
And you use big library like rem,
Yeah.
which has a lot of C++ code, and then you lose syntax hiding and all this stuff often. So
It's definitely doing tricky stuff. The RX team, or the RxSwift team, definitely pushes Swift to its kind of limits.
mhm.
And so Xcode, I think, sometimes can struggle with that, but it definitely clarifies the way you write your code, I think.
Yeah.
Which usually we care more about code quality than performance,
Yeah.
unless we're doing a really, intense app. So
And
we've been pretty happy with it.
Also, it's not too hard to confuse Xcode and push its limit. So I wouldn't blame RxSwift for that.
That's true. Yeah, we like it overall. Obviously, there's some pain points, some gotchas, but it's been working very well for us. We've been doing MVVM pretty much consistently in all of our projects, and it's helped a lot adopt that model. So we're fans.
Yeah, hence.
I've used Frida to trace function calls in applications, but not applications that necessarily use RxSwift. If I were to theoretically trace the function calls of the program right before, dynamic kind of a dynamic trace, as the program ran right before it crashed, for instance, would you think that would be an accurate way to kind of assess where the signal last came from right before it crashed, or is there too much of a difference in time to be able to narrow the
Question.
scope down?
I feel like you'd get into the same stack trace hell, but that's a good question. I don't really know the
You
answer.
repeat the question.
It's basically we're talking about Frida and the inspecting the code as it's running, and if you were trying to catch like what function fired right before the app crashed in an app that was using Rx, would you see anything meaningful, or would it just be obfuscated Rx or realm or something? I don't know. My feeling would be that it wouldn't be helpful because it would just be Rx code, but it's hard to say really.
Yeah, I think on if we can do live debug section instead of looking at the crash log and fabrics, I think what we usually do is we try to put breakpoints and all the exceptions that we might expect to happen, and instead of getting all the stack trace hell, we can get the breakpoint at the exception, and we can trace to whatever that's causing the exception instead of letting it crash and look at the crash log, or the stack trace when it crashes, then we get back to the stack trace we have.
So you still have to have some sort of hunch on where
Yeah,
you think about
yeah,
it.
yeah,
Does RxSwift have on error handling?
yeah. We have one there.
So if an exception is being thrown, you can basically chain it in your observables and catch it.
Well, you
Not
can handle Rx errors. I don't know if you can like cascade down
Right.
exceptions.
On RxJava, for example, if your method throws an exception, then the next subscriber will, or next observer will catch it basically and emit an on error with that particular throwable.
Yeah, I'm not sure.
And
if
then you
that's-
can catch that and handle it, log it, or do some special, or even on Rx there are chains that say, oh, on error, then return actually the default value, or do something else, or return another observable that handles the error condition. If you don't do anything, then yeah, boom, then it's over.
Yeah, we definitely have the on error capabilities. I'm just not sure if it wraps exceptions, like vanilla exceptions.
Okay, yeah.
If it does, that's useful. Was there a question back there? Oh,
It's a lot harder to get exceptions in Swift because of things, because of the excessive amounts of type safety and the lack of nullability in that language. So, is that what you're referring to? Like the things that get passed through and throw an exception because of some sort of like not initialized exception or?
IO exceptions, file not there exceptions, those are, of course, if you have
Yeah.
null pointer exceptions on Java are famous, of course.
Yeah.
But there can maybe format exceptions, you send a string that's not a number, you expect it, and your parser goes haywire. I don't know, there's all kinds of stuff can happen.
Yeah, I think Swift compiles a lot of that, so you find that at compile time before it runs. which I think reduces the risk.
Even if for example, you get data from the server and it's corrupted, you can compile it, but then it says like, hey, you cannot stick this string into a proper number.
Your deserialization would fail.
Yeah.
And that wouldn't necessarily throw an exception unless you told it to throw an exception.
Yeah, and in Swift you generally don't, we try not to ever do like failure or exception. There are obviously cases, but usually for typical situations like that, we don't. We would just throw error pop-up or something.
Yeah, I have a related question actually. So like Rx has like subscribe, on next, on error, all that sort of stuff. Say you have a throwing function, so you're using like Swift's error handling API, and it throws a custom error type. Is that caught on error, or does that just not appear?
I'm not sure.
It depends on how you integrate it into Rx. So it is entirely possible for you to just say, I'm gonna, I catch that exception and pass it through the Rx on error system. Yeah, so you can pass it through.
So you would call you would manually call on error and pass in.
Yeah, so when you go to implement your own observer, right, you create your own driver, you attach it to an existing UI. As part of that, you can say on next and pass down new data. You can say either on complete and pass whatever finalized, well, with on complete you don't pass it, you just say we're done. Or with on error you can actually say, oh, here's something went wrong, here's what went wrong. And then that's passed through the stream back. So if you're watching for it, you go, oh, if it went haywire, stop. Or, everything's good, pass it through the rest of the mapping and filtering buckets and stuff.
So going back to part of the best practices section, you have the